Good to have you once again, where we are going to continue from where we stopped on relative molecular masses. In our previous class, we looked at some examples on how to calculate the relative molecular masses of substances. Of course, we said the relative molecular masses of substances can be calculated by summing together the relative atomic masses of the component elements that makes up the compound. So now let's take a look at more examples today. And we have here, calculate the relative molecular mass of lead-2 trioxonitrate 5. Lead-2 trioxonitrate 5. Of course, lead has a relative atomic mass of 207, while nitrogen has a relative atomic mass of 14, and oxygen has a relative atomic mass of 16. So by multiplying this with the number of atoms present in each element, we can simply determine the relative molecular mass of lead-2 trioxonitrate 5 as follows. So we have Pb NO3 2. So this is the relative molecular, this is the molecular formula of lead-2 trioxonitrate 5. So here we can simply, lead here has a relative atomic mass of 207 plus, you put your bracket, then we have our nitrogen here is 14 plus 3 multiplied by 16. Then all multiplied by 2. Of course, these 2 here outside the bracket multiplies both the nitrogen and the oxygen. Take note. So we have here 207 plus bracket 14 plus 3 multiplied by 16 give us 48, all multiplied by 2. Of course, we have 207 plus 62 all multiplied by 2. Of course, I'm trying to take it gradually so that you will understand. So we have 207 plus 124 to give us 331. So that is the relative molecular mass of lead-2 trioxonitrate 5. If you are asked to calculate the relative molecular mass of lead-2 trioxonitrate 5, what you're supposed to have as your final answer is 331. That is the correct answer. It is as simple as that. Now let's take a look at the second question here. Calculate the relative molecular mass of copper-2 trioxonitrate 5. Copper-2 trioxonitrate 5. Of course, copper-2 trioxonitrate 5 is made up of copper, nitrogen, and oxygen. So we have Cu bracket NO3 bracket 2. Okay, calculate the relative molecular mass of copper-2 trioxonitrate 5. Of course, copper has a mass number of 64 plus bracket 14 plus 3 multiplied by 16 all multiplied by 2. Okay, so we can have 64 plus 14 plus 48 all multiplied by 2. This will now give us, 64 plus 124. So if you, by adding this together, it will give us 188. So that is the relative molecular mass of copper-2 trioxonitrate 5. It is as simple as that. So having looked at that, let's take a look at more examples on how to calculate the relative molecular mass of substances. Let's take a look at the next question here. Calculate the relative molecular mass of sodium trioxocarbonate 4 decahydrate. Sodium trioxocarbonate 4 decahydrate. This, in ordinary sense, may look very, very difficult, but it is very, very simple, provided you follow the simple steps. Okay, now we have sodium trioxocarbonate 4 decahydrate. Of course, this compound is simply referred to as a hydrated compound. Hydrated substances are substances that have water of crystallization. When they are exposed to the atmosphere, they absorb water and they become hydrated. So this is an example of a hydrated salt. So we are going to calculate the relative molecular mass of sodium trioxocarbonate for decahydrate. Of course, this will give us 2 multiplied by 23, which is the relative atomic mass of sodium, and 12, which is the mass of carbon, plus 3 multiplied by 16 plus 10 multiplied by bracket 2 multiplied by 1 plus 16. Okay, 2 multiplied by 23 will give us 46. Give us 46 plus 12 plus 48 plus 10 bracket 18. Okay, so this will give us 46 plus 12 plus 48 plus 180. Okay, so by adding this together, it will give us 286. So that is the relative molecular mass of sodium trioxocarbonate for decahydrate. It is very, very simple. Let's take a look at our last question here, which is aluminium tetraoxosulfate 6. Calculate the relative molecular mass of aluminium tetraoxosulfate 6. So aluminium tetraoxosulfate 6 has a formula Al2 bracket SO4 3. Okay, this is aluminium tetraoxosulfate 6. Of course, aluminium has a mass number of 27. So multiplying by 2 plus into bracket, the mass of sulfur is 32 plus 4 multiplied by 16 all multiplied by 3. So this will give us 54 plus bracket 32 plus 64 all bracket multiplied by 3. So this will now give us 54 plus 96 multiplied by 3. Of course, the resultant of this will give us 342. So that is the relative molecular mass of aluminium tetraoxosulfate 6. So with that, we've come to the end of today's class on relative molecular masses of substances.